Okay, in 4.1, exercise 4.1, not the self-test, we have two balls chosen from among 8 whites, 4 blacks, and 2 orange. We're going to win $2 for each black and lose 1 for each white, and I think it's assumed that nothing happens if we get an orange. So the question now is the different values that we could get. So notice that we could, if we win on both cases, we'd get 4. If we lose on both cases, we'd get -2. If we win 1, get 2, and lose 1, we'd end up winning 1. If we win 1 and get a neutral, we'd get 2. Get neutral on both, in other words, get orange on both, we get 0. And if we get neutral on one and a lose on the other, we'd get this -1. So that's why we get these 6 different outcomes for x. And then in any given one of these, we're just looking at the different number of combinations. So for example, in order to get 4, we need to win both times. So we need both of our balls to be black. So we're taking 2 out of the 4 black balls divided by the 2 out of all 14 balls, the number of ways we could select 2 out of 14, and that gives us 6/91. We could also look at this as chance of getting a black ball on the first would be 4 out of 14, so 4/14 times 3/13 on the second one. That would be another way to get this 6/91. And they just go like that. Let me just pick another kind of arbitrary one here. X equals -1, so we need to lose 1 and win 1. So this 8 choose 1 is choosing one of the whites, or sorry, we need to lose 1 and get a neutral. So this is choosing one of the whites and one of the 2 oranges out of choosing 2 out of 14. Notice that we're not concerned about order here in the numerator or in the denominator. Another option would be, of course, to order these. So multiply this by 2, so that puts the 2 in order on top. And then on the bottom, instead of this, you would just have 14 times 13. And that would put the numerator and denominator in order, and that would still give you the 16/91. Okay, number 3 is not shown. This is 3 dice are rolled, and so you could get anything from 1 to 6 on any of those. I thought maybe a spreadsheet might be nice. So notice if you got a 1 on all 3 rolls, you'd get a 3. A 6 on all 3 rolls, you'd get an 18. So these are the different values. Anything in between is what x could take on. So how many ways could we get a 3? Well, we'd have to get 1 on the first, 1 on the second, 1 on the third. So there's really only one way. Notice that this is symmetrical, so as soon as we find for 3, we also know for 18 there's only one way, because we'd have 6, 6, 6, evil number for some, and that would only be one way of getting that 18. Now 4, we have to get 2 1s and a 2, but it could be 1 1 2, 1 2 1, 2 1 1, so there's actually 3 different ways there. Which means there's also 3 different ways of getting a 17. 5, we could get either 1 1 3 or 2 2 1. Now each of those would have 3 ways of doing it. Essentially, the 2 2 1, we choose the spot for the 1, so 3 choose 1. The 1 1 3, we choose the spot for the 3, so 3 choose 1. So that gives us a total of 6. And notice we're kind of honing in here in the middle. The further we go, the harder it's going to be. So 6, maybe I should have a way of listing out the different possibilities here. So again, this was 1 1 1. This could have been 1 1 2, or well, that was the only way. This could be 1 1 3 or 1 2 2. Now when we get to 6, we could have 1 1 4. 1 2 3 or 2 2 2. So there's 3 different options here. The 2 2 2 only has one way of showing up. And the 114, just like these two, has 3 ways of showing up because we choose the spot for the 4. The 1, 2, 3, notice, could be in 3 factorial different ways. So this gives us 1, this gives us 3, and this gives us 6 for a total of 10 ways. Same down here, 10 ways. Now every time we add 1, we're starting to add a possibility of another way of getting that number. So we still have our 1, 1, 5, our 1, 2. Notice I'm following the same pattern for my first 2 numbers to kind of create an ordered list here. Gives me 1, 2, 4. In this case, I can also do 1, 3, 3. And then finally, I could have my first one be a 2, in which case I would have to have 2, 2, 3. So there's going to be 3 of these. Essentially what we're looking for is if all 3 are the same number, there's only going to be one way to do that, like the 1, 1, 1 and 2, 2, 2. If there's a double number, like the 2, 2, 3 or the 1, 1, 5 or the 1, 3, 3, we're just going to choose a spot for the 2 doubles, 3 choose 2, or choose a spot for the other one, 3 choose 1, same thing. So each of those would give us 3 options. So anything with a double will be 3, so that's 9 right there. This is going to add on 6, so that'll be 9 plus 6 is 15, and that also gives us 15 down here. So I'm not going to keep going, but you see the pattern, and it is going to get harder. We can use the fact that this should total up to 216. You may notice that we have a pattern going here. We add 2, then 3, then 4, then 5, and you may wonder, is this going to continue? Well, yeah, it will, in this sense, because here we can get 116. Notice though, when we go to 9, we can't get 117. So at this point, it starts to decrease the rate that we're going. So the pattern here does not continue because we can't get 7s on the dice. So you could actually continue the pattern. So in this case, it would be 28, but minus the 117s. So that would be 25, 25, and now, actually, maybe I should go ahead and finish. So my sum here is 162. I know that my total sum should be 216, 6 times 6 times 6. So maybe just try this down here. 216 minus 162, get 54. If I split those up, 27, 27, and I might try this just to check. Then the probability of getting each of these is basically just the number of ways times 1 divided by 256, because they're all equally likely. So that would be the probabilities there. If you had to figure out any one of these, essentially you're just figuring out the number of ways to do it, figuring out the number of ways within each set of numbers, and then multiplying that by 1 over 256. Okay, number 5, we have the difference between the number of heads and the number of tails when a coin is tossed n times. Key thing here is every time we toss the coin, the difference is going to change by either, well, it's going to change by 2 in one direction, because either we're going to have 1 more heads and 1 less tails, or 1 more tails and 1 less heads. So it's kind of, if you follow baseball, it's like if the top 2 teams play each other, one of them is going to win and the other one's going to lose, which is kind of a double bonus for the winner, because not only did they win a game, but also their competitor lost a game, versus a situation where maybe just the first place team is playing someone, so even if they lose, the second place would only go up half as much as if the first place won and the second place lost. So that's why this goes by 2 every time. And what I would suggest is just plug in some example values there. So say a coin is tossed 3 times, n equals 3. Look at the different ways. You could either have 3 heads, 2 heads, 1 tail, 1 tail, 2 heads, or 3 tails, and then in each case take the difference between the number of heads and the number of tails, and you'll see that it follows this counting by 2 pattern basically. 4.7, there are no answer here, but dice rolled twice, maximum value to appear in 2 rolls would be 12, minimum would be 2. The maximum value, sorry, would be 6, minimum value would be 1, and the sum of these 2 rolls could be anything between 2 and 12. The value of the first roll minus the value of the second roll. Well, the most we could have is if the first roll is highest and the second roll is lowest, so that would be 6 minus 1 would give us 5. The lowest we could have is if the first roll was low, a 1, and the second roll was very high, a 6, so that'd be negative 5. And then we could hit anything in between there, including 0 if they were the same number. So negative 5 to 5 would be the range of values there.